Okay, so algebra, we are in chapter 6, section 5, solving absolute value equations. Absolute value. We've talked about this concept already this year, absolute value. What is the absolute value of negative 3? The absolute value of negative 3 is 3. Good. And the absolute value of 3 is 3. They're both 3, right? And so the definition of absolute value is what? Madeline? Good. The distance from 0, right? The distance, positive distance. Distance is positive from 0. So we just stated that the absolute value, actually we stated this. Whoops. We said the absolute value of 3 equals 3. And the absolute value of negative 3 also equals 3. Okay? So if I had asked this question, the absolute value of some number equals 3, what are our possible solutions? What are the solutions of the absolute value of x is 3? Oscar? Both, negative 3 and 3. There are two values we could place inside of this absolute value here, right? There are two values that would make this statement true. Two solutions that would make this statement true. 3 and negative 3. So today we're going to see that we can have a lot more going on inside of the absolute value than just a single variable like this. Okay? So let's take down the rule. What more could be going on? So solving an absolute value equation. Look at, we can have what looks like a two-part equation. We might have to undo a couple of operations that are taking place in order to find the value of this expression inside of the absolute value. So when we have an absolute value equation, we could write it as, in two ways. We could say ax plus b equals what? C. Good. I heard somebody say ax plus b equals c. But that entire expression, ax plus b, could also equal something else. What could it equal? Let's look back up at this example here. We said the absolute value of x equals 3 has two solutions. This could equal 3, or this could equal negative 3, right? Look at this. So this expression inside of our more involved equation, ax plus b, could equal positive c, or it could equal negative c. Okay? So there are two possible equations to solve. Or there are two equations to solve. One equals c and one equals negative c. Okay? So let's try this with some examples. The first is the least important. We're getting away from this one, but this is just like the sample I just used. Solve the absolute value of x equals 9. Anderson, what would we say? X equals 9 or negative 9. Good. Okay, both solutions make that statement true. Okay, this is more interesting. When you see absolute value expressions that have more than a variable in them, I want you to use this strategy, okay? I want you to draw two arrows. One goes this way, one goes this way. Because we just stated in the rule that x plus 4 could equal what, Matthew?
X plus 4 could equal 3.
Or we have x plus 4 could equal negative 3. And you must remember to write it both ways, because these answers are not going to be opposites like we saw up here. These are not going to be opposites. Let's see what happens when we solve these. When we solve this first one on the left, what are we going to do to both sides, everyone? Subtract 4. Subtract 4. So x equals 3 minus 4, which is negative 1. But when we subtract 4 in the second equation, X equals negative 3 minus 4, which is negative 7. Good. So we do not have just one value, negative 1, and its opposite 1, do we? Let's try these back in the original expression. If we take this solution, negative 1, and substitute, negative 1 plus 4 is 3, and the absolute value of 3 is 3. Good. Plug in negative 7. Negative 7 plus 4 is negative 3, right? And the absolute value of negative 3 is 3. Okay? Good. The mistake would be somebody stops here with the first one, and they say we have negative 1, and so we have 1. But when we plug 1 into this equation, 1 plus 4 is 5, and the absolute value of 5 does not equal 3. Okay? So you must go two ways. Okay? You must draw these arrows. Okay, so let's solve this. R minus 7 equals 9. Want to do it, Hank?
Yeah, sure.
Okay, so pause the video, come back and see how it went. Okay, so we have a nice pair of solutions. We have R equals 16. 16 minus 7 is 9. So the absolute value of 9 equals 9. And then negative 2. Negative 2 minus 7 is negative 9. Absolute value of negative 9, 9. Okay, now we can add a little level of complexity here. We can have other stuff going on around that absolute value. Okay? So what might we do first here? I mean, the entire expression is not in the absolute value. So what might we do first? What do you think, Johnny? So that's a logical thing to think, isn't it? Distributing the 3. But the problem is that expression in there potentially is two very different things, right? So, and what's going on, that 3 is not being affected by the absolute value. So we're going to do something different. Rather, we're not ever going to distribute across an absolute value. We're going to, Sydney? What do you mean? Not quite yet. Sabrina? Good. We isolate the absolute value. That's exactly right. Okay? We're going to make sure that we get it alone. It's a grouping symbol. We want to get it alone as though it was a variable, and then we'll go two directions and solve it. Okay? So Sabrina, what do we do first? And that leaves us with 3 times the absolute value of 4x plus 2 equals, good, 18. Divide by 3, because we really have two big factors. We have 3 and this big absolute value of 4x plus 2. So we'll divide both sides by 3, and those 3's are multiplicative inverse. Okay? So we end up with the absolute value of 4x plus 2 equals 6. Okay, so at this point, we go two directions. We have two possible equations to solve. Ellie, what's one of them?
4x plus 2 equals 6.
And the other?
And 4x plus 2 equals
Plus 2 equals negative 6. Good, and now we simply solve these two. Okay, so, Kathy, you want to walk us through that? What do you do?
First on the left one, I subtracted 2. And then I divided the equation by 4, and I got x equals 1. And you can do the second one also.
Sure.
On the second one, I subtracted 2 also to the side, and I got 4x equals negative 8. And I divided by 4, and I got x equals negative 2.
And I'm not going to fit this in. So we have over here, I'm going to write it x equals, did you say negative 2? Negative 2. Okay, two solutions. X equals negative 2, x equals 1. Let's try these in the original big complicated thing. Okay, so let's substitute 1. And 4 times 1 plus 2 is? 4 times 1 plus 2 is?
6.
6 times 3?
18.
Minus 7.
11.
There you go. How about negative 2? Negative 2 times 4?
Negative 8.
Plus 2?
-6.
Absolute value of negative 6
Yes.
times 3
18.
minus 7,
11.
11. They both are true. Okay, good. Let's try it again. Do I have a couple volunteers? Pause the video and come back and see how these went. We have this one and we have this one. I'm going to take a couple of volunteers. Okay, good. So we have, in this case, subtracting 4.1 from both sides, dividing both sides by 2. The absolute value of S equals 7.4. So S could equal 7.4 or negative 7.4. And in the right, we have adding 5 to both sides and then dividing both sides by 4 in order to get the absolute value isolated. And then draw your arrows, 2 directions. T plus 9 could equal 6, or T plus 9 could equal negative 6. And we end up solving that for negative 3 and for negative 15, which are the correct solutions. So you could try them back in the equation and you would find that they're true. Okay, very good. And there you go.